Hey guys, this is Carrie, and this is the answer key video for the Regents. This will be the last video that I shoot this year, but I think it could help you guys for your test tomorrow. So here we go. I'm so happy to see this question as the first question because it's just inverse operations to solve for x. So we get 87e to the 0.3x equals 5918. And to solve for x here, we divide by 87 on both sides. That gives us e to the 0.3x equals, I'm just using my computer calculator here to do that, 68.02299. Then to cancel out base e, we do ln on both sides. That gives us e to the 0.3x is equal to ln of both sides. Let's see what we get. 4.2199, or 98. Sorry, we did ln on both sides. Ln and e should have canceled out here, so the correct side here would have been 0.3x. Last step, divide by 0.3 on both sides, and that gives us x equals 14.066, which is answer choice 4. A researcher randomly divides, so the researcher is the one dividing 50 bean plants into two groups. He puts one group by a window to receive natural light and a second group under artificial light. He records the growth of the plants weekly. Which data collection method is described in this situation? So it is a controlled experiment, and the reason why is you've got your control group and you've got your experimental group, the group by the window and the group with artificial light. Hopefully that doesn't cause my pencil to die here. And we've got let's see. Okay, this is gonna be annoying because I don't have much flexibility in the wire, but I'll charge it a little bit. Okay, so, and then also the researcher is the one. Oh no, and it disconnected from the Bluetooth. All right, so I'll have to reconnect here. Okay, so the researcher is the one randomly dividing. This is so annoying. Hold up. Okay, cool, the pencil is connected again. All right, so I won't be able to charge the pencil. Hopefully it just survives forever. Okay, and the researcher divides it, so it's not an observational study. Next up for f of x, which of the following would not result in a polynomial expression? A polynomial expression is one that looks like this or whatever. It's powers of x that are being added, positive powers of x, perhaps with coefficients. Some can be negative. And sometimes with a constant term. So let me prove the first one to you. This one is a polynomial because if you take x squared plus 9 and you add x plus 3, that's going to give you x squared plus x plus 12, which looks exactly like the one that we just indicated. F of x minus g of x is going to look very similar, except with some negatives. F of x times g of x is x squared plus 9 times x plus 3. When we distribute these things out, it's pretty evident that we're going to be getting a polynomial, but to prove it, that is definitely a polynomial. So it's got to be choice 4. In fact, division is the only operation that may not result in a polynomial when you combine two polynomials. However, to prove it, you do x squared plus 9 divided by x plus 3. And this cannot be factored, so you can't reduce this at all, and you're stuck with something that looks pretty different from the other equations that we got. This is not a polynomial. Next up, let's see. Consider the function p of x equals 3x squared plus x squared minus 5x, and the graph of y equals m of x below. So this one threw me off the first time I read it. There are two different functions here. There's p of x, and there's m of x. So let's see. For p of x, we want to figure out how many roots this has. A root is something that makes it equal to 0. So we set this equal to 0, and then we solve for x. So we get 0 equals, factoring out the x, 3x squared plus x minus 5. So one solution that we get from this is x equals 0. To find the other solutions, we have to use the quadratic formula. So a b is 1, and c is negative 5. So we get x is equal to negative 1 plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, which is 6. So x is equal to negative 1 plus or minus the square root of, this is 61 over 6, I believe. I may have made a mistake in the math, but I don't think so. The important thing, though, is you can tell, because this is a positive number, that you're not going to be getting any imaginary numbers. So you're going to be getting one solution from adding, one solution from subtracting, and x equals 0 for a total of 3 solutions that we expect from the highest power being 3. So we can eliminate choice 2 and choice 3 because p of x needs to have 3 real roots. For m of x is the one that's graphed below. The roots of this are when it's 0, so we have those as our x-intercepts. So m of x has 2 real roots, not this one. So it's choice 1. Next up, for choice 5, this is the classic polynomial division question. So we have 2x to the 4th plus 8x cubed minus 25x squared minus 6x plus 14 is going to be equal to, this is going to be equal to our quotient. So we multiply by x plus 6 on both sides to find that quotient. And let's see what we get. X times 2x cubed would give us 2x to the 4th. But when we multiply 6 times that, we get 12x cubed. We want 8x cubed. So we'll have to put a negative 4x squared here. X times negative 4x squared is negative 4x cubed. Those do combine to make 8x cubed. That also gives us negative 24x squared. But we want negative 25x squared, so we need to have a minus 1 here to give us x minus 1 is negative 1x, or sorry, it should be negative 1x. These combine to make negative 25x squared. Then we get minus 6x, but we don't want 6x. We do want minus 6x, that's great. So then lastly, we move on to trying to make 14. So x times what number will give us 14? Well, that doesn't quite work. There's x times the number is going to give us something with x. So it must be that the 14 is outside of the parentheses as a remainder. So that's answer choice 3. That was a pretty tough one. For number 6, this is f of x, which equation represents the inverse of g of x. So inverse is, well, here's the original equation. Inverse is what you get when you switch the input and output. So it becomes this. And then we solve for y. Minus 8 on both sides gives us this. Times 2 on both sides gives us 2x minus 16 equals y. So here we go with that. Number 7, probably the easiest way to do this one is to plug in the answer choices. You can solve it directly by squaring both sides. But since we'll have to check the answers anyway, I think we should just plug into both sides here. So plugging in 5 to both sides gives us square root of 5 squared minus 4 times 5 minus 5 equals 2 times 5 minus 10. This is 0, and 25 minus 20 minus 5 is 0. Square root of 0 is also 0. So 5 works. That means answer choice 2 is out. Next up, I'm going to check answer choice, I guess, 3. So let's check if 7 works. Actually, yeah, let's check if 7 works. So we get square root of 7 squared minus 4 times 7 minus 5 equals 2 times 7 minus 10. This is 49 minus 28 minus 5. 49 minus 28 minus 5, so that's 21 minus 5. That's the square root of 16 equals 14 minus 10. That looks good. We're going to get 4 equals 4. So 7 also works, so we can eliminate this one because 7 works. Lastly, we check 3. When you plug 3 in, you get square root of 3 squared minus 4 times 3 minus 5 equals 2 times 3 minus 10. this is going to be negative 4 on this side. 9 minus 12 minus 5 is 9 minus 12 is negative 3. Minus 5 is negative 8. Oh, it's totally off. These are not equal to each other, so 3 is out. So we get answer choice 3. Okay, so I'm having some issues with the pencil dying, so I'm going to shoot this part over again. Stephanie found that the number of white-winged crossbills in an area can be represented by the formula C equals 550 times 1.08 to the t power, where t represents the number of years since 2010. Which equation correctly represents the population of white-winged crossbills in terms of the monthly growth rate? So the only thing that's going to be different between ours is this value and the growth rate per month. So what we basically need to figure out is which of these 4 equations is equivalent to the one that we started with before. So thinking about how to convert from years to months, C is equal to 550 times, it looks like they're all 1.00643, so we don't have to distinguish that between them. Now, T is the number of years. We want it to be in terms of the monthly growth rate, so this should be compounding not every year, but 12 times per year. So if 1 year goes by, we really want the exponent to be 12. If 2 years go by, we really want the exponent to be 24. It should be 12 times as frequent, so this should be 12t in the power. So it is choice 2. And if you check it, another way to check it is if you take choice 2 and you do 550 times 1.00643 to the 12t, you can raise it to the 12th power part first. And when you do that on your calculator, what you'll see is 1.00643 to the 12th power gives you 1.08. And so it simplifies to the same equation that we started with, because we still have to do it to the t power part. All right, problem number 9 is a quadratic formula problem. We've already seen one of these. So we set it equal to 0 by adding 7 on both sides. And then we get this equation, and then we do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative 2 plus or minus the square root of 4 minus 4 times 3 times 7, all divided by 6. X is equal to negative 2 plus or minus the square root of 4 minus 12 times 7 is 84, so 4 minus 84 all over 6. X is equal to negative 2 plus or minus the square root of negative 80 over 6. Right away, we see the square root of a negative number. So that's going to be x is equal to negative 2 plus or minus I times the square root of 80 all over 6. And this still isn't one of our answer choices. But it is apparent which one is the correct answer. It's got to be 3. Let's see why. Well, because it's the only one with I, but let's see if it really works. Negative 2 plus or minus I, and then we break square root of 80 down into, let's see, 2 times 2 times 2 times 2 times 5 divided by 6. You just use a factor tree to do that. And then you've got 2 groups of 2's. So that leaves with x equals negative 2 plus or minus 2 and 2. 2 times 4, 2 gives you 4. 4i square root of 5 over 6. And this whole thing can be reduced by 2 on top and bottom, because all of these coefficients are divisible by 2, and that gives you negative 1 plus or minus 2i root 5 all over 3, which is equivalent to this. The average depreciation rate of a new boat is approximately 8% per year. If a new boat is purchased at a price of $75,000, which model is a recursive formula representing the value of the boat n years after it was purchased? So in the first year, I guess it's going to be A0 here. We've got $75,000 as the cost of the boat, and each year it loses 8% of its value. So that means that the next value will be the previous value, a sub 0 in this case, times 100% minus the percent that it loses. So A1 would equal A0 times 92%, which is 0.92. But in general, what we could say is to get to the nth boat, nth year value of the boat, A sub n is equal to the value of the boat in the year before, which is A sub n minus 1, the previous value of the boat, times 0.92. So that is choice 4. Given cosine of theta equals 7 over 25, where theta is a standard position terminating in quadrant 4, and sine squared theta plus cosine squared theta equals 1, what is the value of tangent theta? Well, for me, I actually ignore the Pythagorean identity here, and I just graph it. In standard position here, it's going to be 4th quadrant. This is theta. We know that cosine of theta is x over r, so this is x coordinate of 7, r value of 25. Using the Pythagorean theorem to find the y coordinate, skipping some steps will give you 24. You can just use a squared plus b squared equals c squared to find that 24. And then we see that the value of tangent theta, well, it's not actually 24, right? Because they're going down, it's negative 24. So it's going to be tangent of theta is equal to y over x, which is negative 24 over 7. Choice 2. For x greater than 0, which expression is equivalent to this? This looks totally horrendous. But if you remember, having roots and powers can be rewritten as fractional exponents. So this will be x to the power of 2 over root 3 times x to the power of 5 over square root is the second root, so it's over 2, divided by x to the power of 1 over 6. And the nice thing about rewriting it with rational exponents is that now we can use our exponent rules. When we multiply two things, we're adding exponents. To add these exponents, let me just write it. So we're going to have x to the 2/3 plus 5/2 all over x to the 1/6. To add these, we need to get a common denominator, so we do times 2 times 2 times 3 times 3, and that gives us x to the 4 over 6 plus 15 over 6 divided by x to the 1/6. This is x to the 19 over 6 divided by x to the 1 over 6. When we divide divide powers, or some bases to powers, the same base to a power, we can subtract the exponents. So that gives us x to the 19 over 6 minus 1 over 6, which is x to the 18 over 6, which simplifies, if you do the division, to x to the 3rd. This is one of the really nice things about rational exponents. They can make monster expressions much easier to work with. For number 13, Jake wants to buy a car and hopes to save at least $5,000 for a down payment. The table below summarizes the amount of money he plans to save each week. Based on this plan, which expression should be used to determine how much money he has saved in n weeks? So we have to find the pattern here. The pattern looks to me like, okay, well, maybe it's plus 3, but it's not, because it doesn't work for the next one. The power is times 5 divided by 2 is 2.5 times 2.5, and if you check it for all of them, that works. So what we have here is we've got a geometric sequence. But the total amount that Jake saves is not going to be the value in week 5. It's going to be all of the money that he saves up, all added up. So what we really want here is we want to know what's the sum of all of these terms, 2 plus 5 plus 12.5 plus 31.25 plus ... And to do this, there's a really nice thing in your reference sheet, so you can look up the formula for a geometric sequence on that. We derived this formula in class by doing the shift method, but now that we're on the test, we can just use the formula. So it looks like for a geometric series, this is the formula. So we go back to where we were on our test. And we get, let's see, S sub n is equal to a1 minus a1 times r to the n divided by 1 minus r, I believe. Let me just confirm that because I don't have the formula page in front of me and I don't want to make a mistake here. So I'm bringing up the formula page on my computer. Yep, that is the formula that we just saw. So then S sub n is equal to 2 minus 2 times r is the common ratio, so 2.5 in this case, to the nth power, because it says n here, divided by 1 minus r, which is 2.5. And that is choice 1. So whenever you see a geometric series, well, this was a geometric sequence, but then it became a geometric series when we added them all up, you can just use the geometric series formula from the reference sheet. Which expression is equivalent to this? All right, so this problem looks terrible too, but this is one of the easier problems on the test, I believe. We just distribute each of these, and we can get x to the 10th, y to the 4th, minus 16, x to the 6th, minus 9, x to the 4th, minus 16. And let's see, is that choice 1? Oh no, it's not 16, it's negative 9 times 16. Sorry about that. That's going to be positive 144. And I made a second mistake. This y to the 4th also distributes here. So, wow, I guess choice 1 is equivalent to it. X to the 10th, y to the 4th, x to the 6th, y to the 4th. Yeah. Oh, no, we got positive and it says negative there, so this choice is not equivalent to it. So it turns out distribution doesn't work. So you could distribute out all these, but that looks like it'd be horrendous to do. So I think actually the best way to do this one is you can recognize that since this and this are in common, it looks like somebody's been doing factoring by grouping. So you get x to the 4th minus 16 times the leftovers, x to the 6th, y to the 4th, minus 9. Now each of these can be factored one more time using a difference of squares, so you get x squared minus 4 times x squared plus 4. And then here we get x cubed y squared minus 3 times x cubed y squared plus 3. And then that gives us x minus 2 times x plus 2, because this can be factored once more, x squared plus 4, x cubed y squared minus 3, x cubed y squared plus 3. And let's see which answer choice is equivalent to this. Oh, hey, look, they didn't even factor it completely. It looks like they got up to this step, and that's choice 4. Okay, cool. Next up, for 15, A is negative 3 plus 5i, B is 4 minus 2i, C is 1 plus 6i, where I is the imaginary number. So you do negative 3 plus 5i minus 4 minus 2i times 1 plus 6i. That gives us negative 3 plus 5i minus 4 plus 24i minus 2i minus 12i squared. We need to remember that I squared is the same thing as negative 1, so this becomes positive 12. Next up, when we subtract these things, we get negative 3 plus 5i minus 4 minus 22i minus 12, because the negative distributes to that. And I think this gives us negative 7 minus 12, that's negative 19. 5i and minus 22i is negative 17i. So that gives us choice 3. Let's see. Okay, next up for choice 16, which of the following is the graph of x equals 3 to the yth power? For this one, what you want to do is you want to solve for y, so you get y equals log base 3 of x. Sorry, I didn't show my work. You do log base 3 on both sides, log base 3 on both sides, and you get this. Then you pop over to your calculator and you graph it. Remember, when you graph it, you have to plug it in as log of x divided by log of 3. So let's see what crazy calculations we have on Desmos. Oh, it reset, great. Y equals log of x divided by log of 3. And that is pretty clearly answer choice 2. The graph below represents national and New York State average gas prices. If New York State gas prices are modeled by g of x, so this is the New York State one, g of x, which expression best approximates the national average x months from August 2014. So this is like a very convoluted question. It looks like there is a translation between these two graphs of down about 0.3 units. So it looks like what we'd have to do is we'd have to do g of x, and then we'd have to do an outside transformation where we subtracted some number, looks like around 0.3, to shift the graph downwards. And it's not quite 100% accurate. I don't really know why they asked this question this way. For number 18, is a student from the high school selected at random? What is the probability that the student is a sophomore? Probability of being a sophomore given that they're in Algebra 2. So we know we're in the Algebra 2 bubble. There are 85 sophomores out of a total of 295 people in that bubble. For number 19, you have to graph both of these equations on your calculator in the y equals menu. After doing that, you'll get two graphs, and they'll intersect at a point, and you have to do second calc to find that point. I can do this on Desmos really easily, but I don't know that it's that helpful for you because you have to do the second calc intersect method, where you pick one curve, the other curve, and then you take your guess to find it on the test. So I'm going to skip doing this one. I only have a couple minutes left before I have to go and proctor, so let's see. It's so funny, we just did this problem before recently too. Which function's graph has a period of 8 and reaches a maximum height of 1 if it is graphed at least one full period is graphed? Okay, so this one, we start off by using the period to find the b value. So when we plug in 8 for x, we want to have completed a full period. We divide by 8 on both sides, and we find that the b value is pi over 4. So these two are out. Now for the next question, we want our function to, or our graph to oscillate and have a maximum value of -1. Let's see. For number 1, if we graph this, this has a midline of -3. It starts off at -7 because the amplitude is 4. So it goes from -7 to 3 to the maximum, which is 1, because 4 up from there is 1. And so I think this one will have the maximum of 1. If you check this one has a minimum of 1. So we have to eliminate it because the maximum is supposed to be 1. 21, given this function, all right, I think I have enough time to finish this one before I have to go proctor. Factoring this one, we have 0 equals m cubed minus 2m squared plus 4m minus 8. We factor by grouping here, m squared times m minus 2 plus 4 times m minus 2. That gives us 0 equals m squared plus 4 times m minus 2. This can't be factored any further, so we set this equal to 0 to solve for m. And we set this equal to 0 to solve for m. Here we get m equals 2. Here we subtract 4 on both sides to give us this. We take the square root of both sides. M is equal to the square root of a negative is I. Square root of 4 is 2. But we get two solutions, so plus or minus 2i. So our solution set is this. Okay, I might come back and finish this video. Hey guys, picking up where we left off. So the height above ground for a person riding a Ferris wheel after t seconds is modeled by this function. This function. How many seconds does it take to go from the bottom of the Ferris wheel to the top of the Ferris wheel? So because this is a sine function, basically what we can think about is this. So this whole thing is 1 period. And we want to know how long it takes to go from the top from the bottom to the top, which would be from here to here. That's actually 2 of the 4 sections, so this part would be half a period. Now there's a lot going on in this function, but in terms of the period, the only part of this that matters, well, it's not the amplitude, it's not the outside shift, and it's not the inside shift. Only the b value has to do with the period. So if we want to figure out the length of one period, then what we do is we set pi over 45t equal to a full cycle 2 pi. We solve for t from here. Pi t is equal to 90 pi. We divide by pi on both sides of the equation, and we get t equals 90. So this is one period. But the part where it goes from max to min, that's not a whole period. That's only half of a period. So 45 is the right answer. Very sneaky. This inside transformation might have also thrown you off, but all that does is it shifts the graph. Let's see if I can do this. It shifts the graph right or left, so it'd move it horizontally, but it doesn't change the length of a period. The parabola described by the equation y equals 1 over 12 x minus 2 squared plus 2 has directrix at y equals -1. So you definitely want to graph this one. Directrix at y equals -1. Sorry, that's unreadable. -1. The parabola, its equation is here, so its vertex is going to be shifted 2 to the right and 2 up. -2, oh no, sorry. 2, 2. It's an upward facing parabola, like this. Well, we know that the vertex is exactly halfway in between the directrix and the focus, so these distances will have to be the same. This is 3 units, so this is 3 units, so the focus must be at the point 2, 5. A fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers that the events D, that a customer uses a drive-thru, and F, that a customer orders French fries, are independent. The following data are given. Well, the probability of ordering French fries in general is 0.8. The probability of ordering French fries and drive-thru is 0.456. Given this information, find the probability of French fries given that it's drive-thru. Well, because these events are independent, it doesn't matter whether it's drive-thru or not. The probability of ordering French fries is 0.8 no matter what. So we're done. That's probably one of the trickiest questions on this test, even though it took no thought other than realizing that they were independent. Okay, for these ones, we got some long answers. This looks a lot like sum and product, but with x to the 4th there. So when we factor it, instead of having x, we'll have x squared times x squared to give us x to the 4th. Now we're looking for two numbers that sum to -4 and have a product of -12. That's -6 and +2, and we are done. It can't be factored any further because this is not a perfect square, and this is not a difference. It seems strange to me that they asked this question the same as they did multiple choice that was like this. So we'll be using exponent rules to simplify these things. So let's see, we've got 2x to the 3 halves. Then we've got to the 1/4 power. So power of a power distributes to the x. So this will be x to the 4 times 1/4. And then also we have to take the 1/4 power of 16. This gives us 2x to the 3 halves. The 1/4 power is really the 4th root of 16 to the 1st. 4 times 1/4, that gives us just x. The 4th root of 16 is what number times itself? 4 times gives us 16. And if you check it with 2, that works. So this gives us 2x to the 3 halves divided by 2 to the x. Or 2x, not 2 to the x. 2 and 2 cancel out. Now we have x to the 3 halves divided by x to the 1st. And we can just subtract these. So when we divide exponents, we subtract, and that gives us, with the common denominator, 2 over 2, x to the 1/2. But it wants it in simplest radical form, so we have to make sure to convert it back to a square root. So this will be x to the 1st power, square rooted. So all of that crazy stuff was just the square root of x. All right, for problem 27, the world population was 12,560 million people, in 1950 and 3,040 million people in 1960, and can be modeled using this function, where t is the time in years after 1950 and p of t is the population in millions. Determine the average rate of change, p of t, in millions of people per year from this to this. Okay, the one thing I didn't underline was average rate of change, and that's probably the most important thing. This just means we're using the slope formula with y2 minus y1 over x2 minus x1. So we need to make our xy table. We want to go from 4 to 8, so those are our x values. And for our y values, we have to plug these numbers into that function. So the one thing to be careful about here is when you put it on your calculator, make sure that you use parentheses for the exponent, because you want to raise e to this whole power, including the 4 or 8, no matter, depending on which one you're doing. So I'm going to do this on my computer calculator, since it will take me too long to type into my iPad calculator. So we have 2,560 e to the parentheses, 0.017185. Oops, my calculator wasn't typing. Oh no, my computer seems to be dying. What's going on, computer? Maybe I will do it on my, let's see, oh no, it's just typing really slowly. Okay, so 0.017185 x, or 5x, and then I'm going to be plugging in for x, 4, and 8. So that would be, I'm getting 2,937.29 around here, but maybe I'll round at the end to 2896, and 2,742.1636. So we have, oh, I actually put those backwards. I'm sorry, guys. Oops. So this one, and this one should have been switched. So this should go here, and this should go here. Okay, I think I have it right now. Okay, so that gives us 2,937.2896 minus 2,742.1636, all divided by 8 minus 4. So let me do this on the calculator. And I'm getting m is equal to 48.78. Hopefully I plugged that all in correctly. Rounded to the nearest hundredth looks good. The scores of a recent test taken by 1,200 students has an approximately normal distribution with a mean of 225 and a standard deviation of 18. So then we can fill in the values. And let's see, 18 to this is 243, 261, 279. Minusing 18 is going to be harder. 207 minus 18 is 200 minus 11, 289. No, 189 minus 18. Sorry, 189 minus 18 is going to be 171. And after all that hard work, it turns out that this graph wasn't that helpful, because we want to find from 200 to 245, which are not any of our sigma values. So we need to use the normal CDF calculator function in order to find this. So the values that you would plug in would be the lowest value in the range, the highest value in the range, the average value, and the standard deviation, which is 18. And if you do this, whatever you get is the final answer. My calculator on Desmos doesn't do this, so I'm going to not use it. Solve algebraically for x. Okay, well, we've got a lot of fractions. With fractions, you want to get a common denominator. So it looks like we'll have -3 over x plus 3 plus, it will be easy to turn these into 6s. So we could have a common denominator with 6. This x plus 3 has to be part of our common denominator, so it looks like the common denominator will be 6 times x plus 3. So to get that, we'll multiply by 6 here. And that will give us not negative 3 here anymore, but negative 18. To get the common denominator here, we'll multiply by 3x plus 3 and 3x plus 3. And that gives us 3x plus 9 on top after distributing. And over here on bottom, we won't distribute. That will give us 2 times 3 is 6, and then x plus 3 separate. This one we have to multiply by x plus 3 on top and bottom to get our 6 times x plus 3 common denominator. This will give us x squared plus 3x. And then over here, we'll have minus, and then this will be times 3x plus 3 times 3x plus 3 to give us 2 times 3, 6, x plus 3 as the denominator. And then we get 3x plus 9 again when we distribute for the numerator. So putting everything together here, putting everything together here, we know that we're going to multiply through by the common denominator, so those all cancel out, giving us negative 18 plus 3x plus 9 equals x squared plus 3x. And then make sure you distribute your minus sign, minus 3x minus 9. These cancel out. Let's see. Well, negative 18 plus 9 combine to give you negative 9 plus 3x equals x squared minus 9. Last steps to solve for x will be to get this equal to 0. And we get 0 is equal to x squared minus 3x. 0 is equal to x times x minus 3. We get two solutions, x equals 0, and here x minus 3 equals 0, which means x equals 3. However, fractions can be dangerous, so we should have done a pre-check. The one value of x that would have given us division by 0 comes from here. X is not allowed to be negative 3, but that wasn't a possibility for us, so here's our final answer, and we're done. Graph 3 sine of 2x plus 2 over the domain 0, 2 pi. So your calculator is not going to be very helpful on this one. However, graphing these, we know how to do it. We're going to start by going up 2, so our midline is 2. That's not x equals 2, that's y equals 2. Now to graph this, we'll use our amplitude. So we'll go up to 5, so 1, 2, 3, up to 5, and then down to negative 1. It's going to be sine, so it's going to be starting at the midline. Now to make sure we get the domain right, we need to solve for the period first. So the period is going to come from the b value, so we set 2x equal to 2 pi. We're wondering what value of x will have this complete a full cycle. We divide by 2 on both sides, and we get x equals pi. So this is one period. So just draw some tick marks. So 4 things would be 1 period, so this is pi. Another 4 things will be 2 periods, which is 2 pi. And that's all we need to do. We need to graph up to 2 pi, so we are ready to graph. So we have midline, maximum, minimum. Oh, I missed one, sorry. Midline, maximum, midline, minimum, midline. And then we put it all together so that we...
Never mind. No, you're recording a video, that's fine. Let's see.
So we put it all together so that we get the second period, so that's midline, maximum, midline, minimum, midline. And that's our second period, so we're done. Okay, great. On to the next one. Solve the following system of equations algebraically. I just did this problem in the homework set. If you want to see this, I believe it was in one of the most recent homework sets. It's a substitution one, so the first step is you just substitute this for y. The factoring ends up being pretty ugly because the numbers are big, but you can just solve for x and y here. For 32, some smartphone applications contain in-app purchases, which allow users to purchase special content within the application. A random sample of 140 users found that 35% made in-app purchases. A simulation was conducted with 200 samples of 140 users, assuming 35% of the samples make in-app purchases. The approximately normal distribution results are shown below. Considering the middle 95%, determine the margin of error to the nearest hundredth for the simulated results. In the given context, explain what this value means. Okay, middle 95%. So we ignore this data and we just use this. And we set up our middle 95%. So that will be 0.350, 0.392, 0.434 would be the 2 sigma value. Then we go back 1 sigma and back 2 sigmas. I really drew that poorly, sorry. Okay, so going back it's 0.042, shoot. Oh, no, that's right. Okay, 0.042. That's going to be 0.308, and back another 0.042 will be back to 266. So it looks like the middle 95% of the data will be between 0.266 to 0.434. I'm going to check the calculations on that just to make sure that we got that right. So 0.350 plus 0.042 times 2, 0.434, good. And then minus the same is 0.266, great, awesome. Solve the following system of equations algebraically for all values of x and y. So this one we're going to solve using the elimination method, where we have to get one column to match. It looks the easiest column to match would be the x's. So we'll multiply by 2 here, by 4 here, and we'll leave this one the same. Putting everything together, that will give us 4x plus 6y minus 8z equals negative 2. For the next one, 4x minus 8y plus 20z equals 12. And the last one stays the same. Now the goal here is to eliminate one of the variables. And because this whole column matches, what we can do is we can pair up these positive ones with our negative one here. And 4x and negative 4x are easily made to cancel. So let's start by pairing up 1 and 3. So if we look at 1 and 3, that would be the first equation and the third equation. 4x plus 6y minus 8z equals negative 2, and negative 4x, the third equation, plus y plus z equals 16. Now before I solve anything, I'm just going to verify these, because if you make one small mistake, will really ruin the whole problem. Okay, those look correct. So adding these equations together gives us 7y minus 7z equals 14. Now let's pair up 2 and 3 for the same reasons, because we have a positive and a negative here. The reason why we're pairing up the second pair is our equation here still has y and z, so we need to get a second yz equation in order to eliminate y or z. So here, when we pair these up, 4x minus 8y plus 20z equals 12, and negative 4x plus y plus z equals 16. These cancel out. This gives us negative 7y plus 21z equals 38. I'm feeling like I did that wrong, but 28, right? That's how you add. So now we'll take these two equations and we'll pair these up to solve one more time. So we get 7y minus 7z equals 14, and negative 7y plus 21z equals 28. And we're in really good shape here because we already have our y column matching an opposite. So when we add these equations, they cancel out. Oh no, my pen just died. I'm not going to be able to finish recording this problem. Let's see. 7y and negative 7y cancel out. This gives us 14z equals 42, and then we get z equals 3, and we plug in to get the rest. my phone or my iPad is dead almost, and my pencil's dead. So I'm gonna stop here, guys. This is the most I could record. I hope that you're able to figure out the rest. But I think this will be helpful for me to get out to you guys before the Regents. So I'm done here. Bye.